Here's a second example for using this formula. And this is ubiquitous, and you also find it everywhere. Okay, the notion that we're going to use an electric field to fight gravity, right? So Carson buses suspends this thing. It's got a mass of 1.5 grams, right? And it's curiously enough, it's called a pith ball. I don't know why. Against gravity, it has a charge of 12. I think pith is, what is it? I don't know. Pine pitch? What is it? I really don't know. 12 microcoulombs, and he is generating the electric field using plates that are 3.5 centimeters apart. What voltage should he use? Which side, top or bottom, is positive? So he's going to hook a little power supply to this, right? Okay. Oh, look at that! I'm drawing the thing wrong. He's got a positive charge like that, and he wants to hook it up, and so he'll have a positive side there, a negative side, and then we'll make this like a variable battery or something like that, right? And he's going to crank it up until the force of electric field equals the force of gravity, right? And I've already given away which side has to be positive. In order to exert an upward force on a positive charge, there has to be positive below it, right, and negative above it, okay? So that's what we're going to do. And the question here is, what's that voltage, or the change in voltage, if we want to be all pure about it, okay? I think what we can say is that the force of electric field is going to equal the force of gravity, right? And the electric field is going to be E times Q, and the force of gravity is going to be M times G. This is classic, isn't it, right? Nothing much to do there, but E is going to be V over X, right? So I'm going to say delta V over X. I'll even say delta X, just because I'm in a good mood, right? Is M times G. So that means we want this guy all by himself, right? So what do? I guess we go, let's do it. M times G, let's put the Q in the denominator, put the X in the numerator. Does that do it? Yeah, it does. Let's try it. Okay, so 0.0015 kilograms, 9.81 newtons per kilogram. Delta X is, oh dear, is it 0.035? Oh my gosh, I'm running out of space. Q is 12 microcoulombs, so 12E minus 6 coulombs. Shouldn't we get new joules per coulomb? Do we get joules per coulomb? Let's see. Kilograms goes away. Newton meters per coulomb. That is actually volts. That's so cool. I'm so excited. Are you excited? I'm excited. 0.0015 times 9.81. Oh, that's supposed to be a 1 there. 9.81 times 0.035 divided by 12e minus 6. 42.91875. Or 43 volts if you only have two sig figs. Yeah, okay, so in these types of problems, you just set electric force equal to gravity, and then oftentimes you have to substitute. I'm using E is equal to delta V over delta X, and I'm substituting that in for E and getting this. And then I think it's easiest to just solve it with the symbols and then plug the numbers in. But at this point, you could just plug in the numbers, and if you want to stab at your calculator with your fingers, you can do that too.